Very warm welcome to all. A very good afternoon to all our guests joining in from the UK. A good evening to all our guests joining in from India and South Asia. And a very good morning to all our guests joining in from the US and South America. Today is the fourth seminar in the second edition of the seminar series on the topic The Digital Future for Business and Society, Emerging Perspectives on AI, Blockchain, and IoT. This seminar series has been hosted jointly by Professor Yogesh Dwivedi, who is a professor of digital marketing and innovation, founding director of the Emerging Markets Research Center, and co director of Research, School of Management, Swansea University, Wales, UK. Our co host for this seminar series is Professor Dr. Ramakrishnan Raman, Director, SIBM Pune, Faculty of Management, Dean, Faculty of Management, Symbiosis International University, and Director, Strategy and Development, Symbiosis. Our entire seminar series is jointly supported by the Center for Technology, Innovation, Management, and Enterprise, that is TIME, by the University of Kent, UK, Digital Marketing and Analytics, SIG, Academy of Marketing, Grenoble IAE Graduate School of Management, a Grenoble INP School of the University of Grenoble Alps, the E-Business and E-Government, SIG, British Academy of Management, and the UK Academy for Information Systems, UKAIS. To tell you something about the seminar series itself, emerging technologies such as artificial intelligence, blockchain, and Internet of Things undoubtedly offer a transformative potential for the augmentation and potential replacement of human tasks and activities within a wide range of industrial, intellectual, and social applications. The pace of change for this new AI technological age is staggering, with new breakthroughs in algorithmic machine learning and autonomous decision making coupled with developments related to blockchain and IoT, engendering new opportunities for continued innovation. The impact of AI and other emerging technologies could be significant, with industries ranging from agriculture, finance, healthcare, manufacturing, retail, supply chain, logistics, and utilities all potentially being disrupted by the onset of these technologies. The seminar series on the digital future for business and society, emerging perspectives on AI, blockchain, and IoT, will present various perspectives from a number of leading expert leaders to highlight the opportunities and challenges posed by the rapid emergence of these transformative technologies. Today, we have with us Professor Dr. Sven Laumer from the Friedrich Alexander University, Erlangen, Nuremberg, Germany. His title and the title that Professor Laumer is going to be speaking to us is on how can artificial intelligence enhance car manufacturing. Professor Laumer is the scholar endowed professor and chair of information systems in the School of Business, Economics and Society at Friedrich Alexander University, Nuremberg, and the deputy director of the Dr. Theo and Fried Scholar Research Center. His research focuses on digital collaboration, digitalization challenges, and people analytics. It has been published or will appear, amongst others, in all journals of the AIA Scholars Senior Scholars Basket, including MISQ, ISR, and JIMS. He serves on the editorial boards of Information Systems Journal and the Database for Advances in Information Systems. He has been awarded the Young Talent Award 2018 by the German Academic Association of Business Research, VHB. When he does not do research and teach digital work and life, he enjoys being a soccer referee, hiking in the Alps, and spending time with friends and family. Professor Laumer, over to you, and we are very keen to hear from you on how can artificial intelligence enhance car manufacturing.
Yeah, Santosh, very much for this kind introduction. I really appreciate to be your guest today and to talk about one of our research projects that we did during the last 2 to 3 years in cooperation with 2 PhD students of mine, Daniel and Quirin, who both also work with Siemens. So there's an industrial PhD cooperation behind that project I will talk today about. It's my pleasure to be here to welcome you all wherever you are in the world. Is it UK? Is it other parts of Europe, India, Asia, America, and so on? It's really great to see how the digital world makes it possible that people and researchers from all over the world can come together to actually think about important topics like how can artificial intelligence enhance car manufacturing? So what does it actually mean? And how can we actually think about a change also in the car manufacturing industry, given that there's artificial intelligence, and how this might be different to other areas where artificial intelligence can be used. Santosh already explained and introduced myself, but I will spend, before I talk about my topic today, a couple of more minutes on what we do at my chair in my team about research that we are interested in. So as Santosh said, I'm the Schoeller Endowed Professor for Information Systems and Digital Transformation of Business and Society. So what we really are interested in is, first of all, the future of work. So we want to understand in various areas, like, for example, car manufacturing, how is work actually organized and how do information technology and especially artificial intelligence help us to support workers to do our work better, more efficient, more effective, and so on. And of course, digital collaboration, like we have seen during the last couple of years, given the Corona situation, is part of the topic. So we have already done in another area work on some research on telework to understand how virtual teams actually can work together successfully. On the other side, we are also interested in people analytics. So we want to understand how we can use data-driven approaches to learn about people and to support people in various contexts. So for example, one of our recent research projects I'm not talking about today, but just give you an idea about what we are doing. We work together with our colleagues from the medicine department to understand how we can actually generate data-driven recommendations for more healthier behaviors that actually matches the context of individuals. Because if you get your recommendation now to walk around, that may be possible because you can listen to me and walk around. But if you would sit in a lecture hall and you would sit in front of me, this might not be a good recommendation that you start walking around while I giving a talk, because I might look very strange if all my audience would walk around at this moment. So we really want to understand the context people are based in to then provide, for example, health recommendations that actually matches the context so that they can actually adapt it so that it leads actually to more healthier behaviors. And given all these constraints that we see around the digital transformation, we are also interested in digitalization challenges. So I'm really interested in technology acceptance and adoption, for example, but I also did a lot of research in the past on technostress, so to understand how technology is actually stressing people. And with our topic of today, where we talk about how artificial intelligence can enhance car manufacturing, different parts are coming together. Because on the one hand side, future of work, I want to understand how artificial intelligence is actually changing car manufacturing. So what is the strategic applicability of AI in this area, and how is it changing organizations in terms of car manufacturers, but also all the different suppliers that work together to produce a car. But on the other side, in terms of digitalization challenges, what is the challenge in terms of adoption? So are car manufacturers actually willing to invest their money in artificial intelligence-based technologies? And if they do so, will a worker accept that there's an artificial intelligence-based system now implemented, and will they follow the recommendations in this regard to improve their work on, for example, the shop floor? So there in this project, a lot of these topics are coming together, so that I will talk today about past and current research activities that we do in my team about this area, and especially about the strategic applicability, the adoption challenges, and I will conclude some practical application and discuss some transferability of this results to general manufacturing processes. So not only car manufacturing, but also other ones. So let me start with the first part, which is strategic applicability. But before we start, I forgot to mention, of course, there is a chance for Q&A. We just agreed before we started that I will give a talk about 30 minutes, and then we have the possibility for Q&A. So if you have any questions, please feel free to use the chat or the Q&A tool during the talk or afterwards to propose your questions that you might have about what I'm talking about. So let's start with the strategic applicability. And what we're really interested in is the question, well, how does artificial intelligence make actually sense for car manufacturers? So what are use cases for the car manufacturing process or the automotive value chain where we actually can use AI? So what are the different possible use cases? And how do car manufacturers actually think about them in terms of the business value, but also in terms of the ease of use, in terms of how easy it is to implement these use cases in the automotive value chain? Because when we consider car manufacturing, this is very different to, let's say, some kind of service business. In a service business, you can easily implement a new technology. But when you talk about manufacturing, we have to understand that there's all these big machines out there in the shop floors, which were built for years and months, and you cannot easily switch an entire shop floor, an entire manufacturing line within a couple of days. So this requires investments. And if this investment is taking place, it requires years to get your cash back. So you actually invest a lot of money for, for example, a car manufacturing line for a specific car that you're going to produce. And it will take years until the investment actually provides you value. So you're not easily changing all these different areas. So investing money in AI and making this change is actually a big decision for a lot of these organizations. And therefore, we did first of all look at to understand what are different use cases, organizations which are possible. And then we used some Delphi study approach to actually make an assessment and a ranking of these general use cases in order to see which are the ones that provide business value and which are the ones that organizations think that they can easily be realized, easily be implemented in the given installed base of the machinery of the systems that they actually use at the moment to produce their cars. So we started in our research to understand the status quo in the automotive value chain. So when you think about the car manufacturing process, it typically starts with the press shop, where you actually build the different parts. Then there's the body shop, where you actually, build the body, then you paint it, and then you in the assembly one, you bring together the body and the machinery that is necessary to actually drive a car, and then typically car manufacturing processes are done, and then you go into sales and after sales and so on. So this is just a very brief overview. So we see different opportunities for AI in the press shop, in the body shop, in the paint shop, in the assembly line, and when we finish the production of a car. And it's typically that we see that this process is complex and very high in terms of the capital investment that you need to do that, because you have to bring together different suppliers, you have to bring together different machineries and to actually come up with a finally built car. So this is a really complex and capital investment manufacturing process. And what we realize is that there is, when we talk to people that actually are managing these processes and are responsible for parts of them, we see that there's kind of a lack of a knowledge and awareness of AI technologies, because this was kind of rather a physical process where you have to press parts, where you have to bring together parts, and then you have to check if this kind of physical process actually was successful and a car is actually able to drive without any error. And therefore, they typically don't have so much knowledge and awareness of how artificial intelligence can actually support the different parts. And therefore, it is typically difficult for managers in that area to select the right use case. And based on the collaboration, the PhD collaboration project and program that we have from our university with Siemens, actually Siemens is based here with a lot of offices and also some manufacturing lines here in the Nuremberg area. We actually said, okay, let's focus on that because this is for Siemens, who is a supplier for many machineries for the automotive process and very important topic. Let's see how that makes sense. And therefore, what we did in our first step was to, first of all, make a literature review to see with all these different manufacturing journals, how they make sense in terms of artificial intelligence in the car manufacturing process. And then we used the Delphi study approach, where we first of all talked with 39 leading experts from different car manufacturers around the world and different suppliers about these use cases. And we used also some kind of quantitative survey-based approach afterwards to make these rankings about these different use cases. So what we see now is, first of all, results from our literature review. We identified 33 peer-reviewed publications that talk about the use of AI in the automotive manufacturing processes. And these are the use cases that they were reported in. First of all, we see that the most use cases that were reported in the literature are about quality control. So if you have made a part of the car or the entire car at the end of the day, there are so many quality control and quality management tasks involved to check if the part that you have produced of the car in the press shop, for example, or when you assemble different parts, if this is done with high quality. And what we see is that there's a lot of visual and non-visual quality control approaches reported in the literature that can be used, for example, with a camera where you look at the parts and then make an AI-based approach to compare the picture that you take with many, many pictures of the same part and make a conclusion about whether this picture or this part is similar to the ones that have high quality or whether it shows a pattern in relation to those of less quality. And we see a lot of use cases in the literature that actually talk about these visual and non-visual quality control programs. And as you can see, the third point here already was the Ford Global Study Process Allocation System, which is a specific process or specific application invented by Ford and then used by other organizations as well, which organizes the production with planning documents written in machine readable standard language to ensure global process consistency, is the third important one that was reported in the literature. So we see a very high relation to quality control in the literature, and then all the other ones like the production forecasting and planning, so to get an understanding how much cars should be built next year or in next month, is already less discussed in the literature. And the more we go down with sequence optimization, energy management, predictive maintenance, which might be one of the most discussed research areas in this area in the public. Because if I talk to people out there about AI in manufacturing, they always mention, well, this is about predictive maintenance so that you understand when your machinery is going to have troubles and you can actually send somebody out there to fix it before it actually goes out of business, or when your assembly line has to stop because some of the machineries are actually not running anymore. So as you can see, there's many use cases, 20 in total, 14 in total. Whereas the majority in the literature actually talks about quality control and visual quality control. Based on that identification of these use cases, we went out and talked to these 39 experts in the first way with qualitative interviews. And we identified 6 additional use cases. For example, we saw that not discovered in the literature, but having in mind when you talk to people responsible for car manufacturing out there in the field, they talk about the autonomous optimization of robot trajectories, they talk about drone routing, they talk about the reduction of robot energy consumption, the maintenance of knowledge management systems, the human-robot integration, and factory energy management as well. So we extended our list of potential use cases from 14 that we identified in the literature by 6. So in total, we have now 20 use cases identified based on our literature work and based on our field work, where we see these are the use cases that we can actually use for enhanced car manufacturing processes by using AI. But when you look at these different use cases here on the slide, of course, implementing visual quality control, so actually having a kind of an impact on the assembly line, that really requires investments, because you have to think about how you reorganize the assembly line when you produce a car, when you want to have an AI-driven visual control system used in that. On the other side, when you do production forecasting or planning, that might not require so many investments because you don't have to change the assembly line. This is rather a standalone system that you can actually use to predict what might happening and then use these predictions and make your decisions about, for example, the staff management, to see about people management, how many workers you need, and so on in the next months. So we see that there are different types of use cases that requires more investments than others. So in terms of their realizability, but we also see when we look at that, that some of them might really provide more business value than others. So for example, if you actually reduce parts with low quality and you can select more of these parts that have low quality out of your assembly line, then you have lower challenges afterwards when the car is actually sold to a customer and used. On the other side, if we use predictive maintenance, for example, it might be that actually the business value at the end of the day might not as high as for any of these other use cases. So what we now did is to get a better understanding of that, we did our Delphi study to first of all talk with the experts, the 39 experts from the car manufacturing industry, and then also use some kind of survey-based approach to ask them about what are the ones with the highest business value and what are the ones that you think that can easily be realized. And when we look at the business value first, what we realize is that the top 4, the top strong group where people actually think that these are the ones that really provide high business value are predictive maintenance, are visual quality control, object labeling and tracking, and sequence optimization. On the other side, in terms of business value, at the other side of the spectrum, the lowest ones, we see that the paint bath composition control, staff assignment, and the worker walk path optimization, so how workers actually walk through the assembly line when they do their work, are the ones where the experts said these are the ones with the lowest business value. So we did this ranking and qualitative assessment of all 20 use cases by the economic and monetary use value, as the 39 experts from the car manufacturers, about, I guess it was 24 ones that we involved in the study, actually told us. And the same we did with the realization. So the question whether how easy the ones can be realized, how much investments do we need to actually use these kind of use cases, and how much change do we need in the assembly line to actually use these use cases. And what we see is that in terms of the top 6, we see object labeling and tracking, robot energy consumption reduction, visual quality control, paint bath composition control, cutout waste reduction, and factory energy monitoring. So you see again some different ones. And in terms of the lowest 4, we see pin packing, sequence optimization, human robot integration, and matrix production or cellular manufacturing. And by using that, we were able to conclude this matrix of use cases of AI and car manufacturing from a strategic perspective. Because what we see here in our top right quadrant are the ones that actually provide high business value and can be easily realized. So managers in car manufacturing industries can now use that results and say, okay, if we talk about AI, let's have a look at those, because these are the ones that actually provide us high business value and the realizability is high. And there we see, for example, visual quality control, we see object labeling and tracking, we see predictive maintenance, factory energy monitoring, cut-off waste reduction, and reduction of robot energy consumption. So this is actually the quadrant that shows us, well, these are the ones that can be more or less easily be implemented and providing high business value. We also see, if we plot this, this matrix here, that there are ones that provide high business value, sequence optimization, bin packing, human-robot integration, and matrix production, that actually are not so easily be realizable. So it needs a lot of efforts to actually bring that into the assembly line, but they will still provide high business value. So there's more investment necessary, but still there might be some value. On the other side, we also see 3 of them, another cluster in terms of paint path composition control, in terms of staff assignment, and in terms of walk path optimization that can easily be realized, but the business value is not the best. So this is part of our first step that we did in this research area. And this paper or these research results are published already in the International Journal of Information Management. So if you're interested to read about this in more detail, there's already a paper out there in the International Journal of Information Management where all these results are described in more detail, but also there's a description giving of all these different use cases if you want to understand them in more detail. The main outcomes from this first part of our work was that, well, there are clear signs of an early development phase of AI in the automotive domain. So people started to think about that, how AI can be used in the car manufacturing process itself. There's a longer history about AI in the car itself. So for example, if you consider Tesla, they're of course using a lot of AI to come up with self-driving cars and so on. But in the car manufacturing process, we see that people have started to think about that and consider use cases. There are use cases, but in fact, there are not so many really implemented at the moment because the challenge is that people want to avoid financial disasters. When they just think about a use case and you have to switch and invest a lot of money to change your assembly line and the use case actually will not provide the business value that you expect it to be, then this might be very easily result in a financial disaster for these organizations. Nevertheless, experts have a clear opinion on which use cases are the most promising ones. So we have realized that the automotive industry actually understands what the best ones are. And we have seen that given the comparison between different organizations, whether they think about or which use case they actually want to talk about depends also on the expertise in that area, their financial situation, their market and competition situation, and the availability of data in the assembly line and their quality. And based on that, we realized that we need to continue our journey in that area to consider also what are actually the factors that organizations and later on individuals will actually adopt these AI-driven approaches in the automotive assembly line, and what might be inhibitors that from an organizational perspective, car manufacturers say, no, we don't want to use that. And if the organizations say yes, how do workers actually respond to that? Because what we see in the literature is a big discussion on that workers actually will overrule AI-based recommendations, for example, in predictive maintenance areas. Also, the machine tells you, I'm going to go out of business in a couple of days because there might be some challenges coming up. Workers still think, well, with my experience that I have for a couple of years working with that machine, that's not going to happen. So they typically are into overruling based on their own feeling and expertise and heuristics that it will not happen what the AI is telling us that will happen. So there might be some individual adoption challenges as well, that people are actually not willing to rely on these AI-driven approaches. So what we did based on our strategic approach, when we understood the different use cases, we went into, first of all, an organizational level adoption study, where we actually tried to understand from a manufacturer's perspective, what are inhibitors and enablers of implementing AI in the assembly line. And second, we also went to the workers at the assembly line to get a better understanding about enablers and inhibitors for the individual workers. And this is my second part, which I want to talk about, where we see that, first of all, we use the technology organization environment model. That was a very common model for explaining organizational level technology adoption. And we went out and talked to a lot of people. I guess it was about 39 organizational decision makers that actually provided us the opportunity to talk to them. And what we see is that there are so many different factors that explains the organizational adoption of AI for the car manufacturing part. The paper the picture that you see is already published as well. It's published as a proceedings paper for the European Conference on Information Systems in 2020. And what we realized is that there are so many factors, especially related to this context, that explains us why organizations in the car industry do or do not want to rely on AI in their manufacturing process, because the black ones that you see are actually factors that were partly touched in a very general manner by the technology organization framework, but not really with a specific regard to the AI-driven approach. For example, we see this factor here, availability of sensor data, and especially in relation to that, the quality of the data that's available. We need to understand that when we want to use AI for these different use cases that we just discussed, the base for that is data that we have and sensors that we use in the assembly line to actually generate the data so that we actually be able to make these pattern recognition approaches. And if I realize that, well, I don't have these sensors, or I don't have so much of the sensor data available, and the quality of my data is not given, then I will not go too much into AI, because the base for AI is my data and the quality of my data. So in a lot of interviews, what we realized is that organizations, first of all, have to do their homework to understand what the quality of the data is that they have available in the assembly line, to then consider what type of the data we can actually use to support our car manufacturing process. Another factor that is that we realized in this area is the upper right corner here, the availability of expertise, because a lot of expertise in classical car manufacturing organizations went into the actual engineering of the assembly line, not so much about AI and software and so on. So what is really a challenge for many car manufacturers is at the moment that they do not have these software and AI skills available in their organization to actually build up these AI-driven support for their manufacturing processes. So this was really a very strong factor as well that was mentioned in many organizations in our interviews use as well. And then another one that actually was interesting was the lack of uncertainty regarding data protection, intellectual properties, and liabilities. So given that we use a lot of data in that regard, organizations responded that they are unsure whether they are actually allowed to use that data. So this was kind of some barrier that they also considered, well, should we actually do that or not? And finally, public funding is another example that I want to mention here briefly, is that, as I mentioned, it requires a lot investments in changing an assembly line in a manufacturing industry. And what organizations told us is, well, yes, we can do so, but what we need is support, public funding support in terms of research projects, etc., so that we are actually able to invest this money to make these use cases, make some prototypes to then actually go into the production line and make everything happen. So funding for these kind of changes was also a very important topic. What we also saw is top management support. I also talked about data quality is another one where many people said, well, if my top management is not really into AI, so why should I change my assembly line with AI if there's not really support from top management? So these were the major organization level adoption factors. And then we said, well, let's understand that at the individual level as well. And there we see some enablers and inhibitors here as well. Another paper that we did based on interviews, also published at the European Conference on Information Systems. It's published in the 2001 proceedings, where Quirin actually did an analysis about the system and information quality related enablers and inhibitors of using AI from a blue collar worker's perspective when they are confronted with the use of AI in their work part of the automotive assembly line. And we see, yes, they have some positive expectations. They think that using AI will make their work more, will provide them more autonomy, they will provide them more reliability, and it actually might be useful for their job. And they think, well, that will support the decision effectiveness and there will be some added value beyond human possibilities. So what we realize on the one hand side is that workers say, yes, given the quality of the system of AI and given the quality of my work that is supported by AI, there is some benefits that I will get. On the other side, what we also realize, and people really talk more about these negative aspects, that workers see a lot of challenges like complexity, dulling of the employees, loss of control, loss of jobs, loss of status, perceived surveillance, transition costs, and black box decision making, because they do not really understand if the AI provides them some recommendation, why this recommendation is provided and why there is some indication that the part in terms of the visual control might be not of high quality, or in terms of predictive maintenance, why the machine might go out of business in a couple of months or a couple of days or whatever. So the black box decision making, and especially their concerns about, do I still have control over my work? Do I still have a job? Do I still be considered to be an expert? That is really important for the assembly of a car, are challenges that people face with AI. And that's the reason they typically overrule AI recommendations during their work. And this was also interesting for us, so that we said, well, let's talk about the implications of that, so that we actually can come back to, for example, our industry partner, which was Siemens, or any other organizations that are interested in that regard, to discuss the practical and theoretical insights on industrial application of AI in general. So we might take away some of these challenges and some of these insights that we've taken away, not only for car manufacturing, but also for any other kind of industrial manufacturing. And what we see is that there are 6 major lessons learned that we can talk about. First of all, there was one quite good quotation. I'm referring now to some quotations to make some conclusions here. One interviewee said to us, don't waste time on AI for AI's sake. Be motivated by what it will do for you, not by how scientific it sounds. What we realized is that in some cases, people just talked about of AI because everybody's talking about AI. They didn't really had a clear sense of urgency, and they didn't really saw that AI was being seen as something that is necessary from every stakeholder involved in the assembly line. So really important here is, in terms of the psychologically induced issues and adoption hurdles, that when you want to use AI in car manufacturing, create a sense of urgency, or identify the sense of urgency, the part of your assembly line process where you actually have the challenge. And then see whether all the involved stakeholders from management and so on actually see the need, that there needs to be some AI-driven approach. Second, bad data, worse predictions. what we realized is that one of the organizational adoption challenges is data quality, because they say we don't have the data available to do that. And in fact, yes, if you have bad data, or if you have less data available, you get worse predictions. So data is the key, and you need to make sure that it is not biased to actually see, yes, this data actually makes good predictions, for example, for maintenance, for quality control, and so on. Third, ensure a maximum of robustness, explainability, and security. We have seen that explainability is a very high concern that individuals raised. So aim for explainability. If not through the algorithm itself, then by involving all affected employees to explain what actually is happening there and why it makes sense to rely on what the AI actually provides as a recommendation in the production line. This is a challenge, as we have seen at the individual level, that the black box character is of the recommendation is actually seen as one of the major inhibitors from an individual's perspective. And therefore, be aware of regret avoidance and perceived sunk costs. That means that get you and your employees' expectation straight or in the right direction. AI can be valuable, that's sure, but it can neither save the world nor a lucid process. Well, you cannot simply say, well, we have a challenge with our production process and now we use AI and everything would be great. No, we need to understand that AI can provide some improvements for some parts of it, but it cannot solve that when a lucid process is designed that the entire process will get better. Fifth, measure your improvements. That includes both measuring decision quality before and implementing and after implementing the new system. When we consider AI for the assembly line in an automotive process, as I said, there are so many investments necessary to do so. So what top management or managers want to know is, what is my business value if I do that? And do you really provide by using AI this business value? And you need to be aware that you should actually be able to show that. And finally, know your employees' fears and address them openly. There's a lot of fear going on at the workers level in terms of job losses and so on. And these are, well, maybe this is really a concern for many organizations because you need the support of the people by using these AI approaches. And if you don't have the support, they will not provide the business value. So what we need to do is we need to take their fears in a really open manner to actually address them in this area as well. But let me conclude my talk. As I said, there are some technology, project management, and people-focused challenges. And therefore, we brought together these different types of recommendations here on that slide that takes again on what I just mentioned in terms of the use cases. Select the use case worth solving. First of all, consider the business value and the realizability of a use case for the concrete assembly line that you're looking at. We have discussed 20 use cases and did some general assessment that might be a starting point for these technology-related assessments. But then ensure that there's data available because data quality is the key to actually use that use case in your organization. And third, ensure technological excellence so that you actually make sure that the AI works. Because if the AI identifies not a part that is of less quality, that might take actually serious challenges. In comparison to Netflix, if Netflix suggests us a video that we should watch and we don't like it, we might laugh and say, well, bad choice, but that's it. There are not really these serious quality management issues involved as it is with manufacturing processes, and therefore ensuring technology excellence in terms of the prediction quality and so on is of really high importance. Second, in terms of project management, as I said, define your KPIs, create ownership, and put especially the customer needs in the center. And finally, in terms of people, expect and be prepared for irrationalities, prepare for the fear of the people, and to open finally the black box to actually create transparency to those who are not really technology savvy in terms of they have not so much understanding about technology that they will understand how actually AI can support their purposes. And hopefully, I have provided you some insights about our research about the use of AI in car manufacturing processes from the strategic applicability until the individual challenges and what the different aspects related to this are. If you want to know more about that, feel free to network with me on LinkedIn. Please feel free to invite me to send me an invitation on LinkedIn so that we can share our connection there. I'm always talking about these issues on LinkedIn as well, and I'm happy now to answer your questions. Thank you very much for your participation.
Thank you very much, Professor Sven. So I'll start off. This is with the questioning. So this has been a very what do you say, an interest area for me, automotive sector and the automobile sector. And you being based out of Germany and research happening in Germany on AI applicability and of AI within the car manufacturing setups. So my first question is probably in this zone, as in, how would faculty or researchers assuage the concerns of workers whenever you are going to make a presentation to the management, because management would probably want to adopt AI technologies within car manufacturing for the obvious benefits that it brings in. But how would that be used to go ahead and tell the workers that your job losses, you don't need to worry about them. There are other areas where we can move them. So how would you go about? Your thoughts on that, sir?
Yeah, I think in Germany, we have a very special situation for the German car manufacturing organizations because we have very strong worker councils. So what typically happens if we talk with management, there's already some worker council representatives involved in the discussions. And if you work with them and you explain them and talk with them and do from the very early beginning on, involve them in your thoughts and in your research and in your projects, they will be supportive. And if they are supportive, then they actually spread the story in the organization and workers getting supportive as well. So on the one hand side, I think that worker councils are a very good approach for actually getting the support of workers for these areas. And this is also what management knows on the other side in German organizations, that there's a strong voice of the worker council in our organizations. So we really need to consider their opinions and their concerns to make an investment in a specific technology like AI successful. So from the German perspective, the worker councils are a very good approach to get into the concerns provided by workers.
Professor Sven, I have a question here. It was a very good presentation, especially with respect to churning out something valuable in terms of research in the cutting edge area, which is AI in the automotive sector. So I was looking at your presentation and there was a graph which you actually created, which is about the business value low and high and realizability low and high, if I remember it right. And you had actually mapped telling low and high, and then you had several aspects like sequencing optimization or visual quality control, or a couple of things that I remember. So what aspects did you take into that business value and what aspects did you take into realizability as two factors? If you can possibly throw some light on it.
Yep. We went, first of all, when we look at this slide, let me go one slide back here again. First of all, we did this in a survey-based approach, and you can see the scale up here. So what we asked them is to evaluate the average business value on a scale from very high, which was 1, to almost none, which was 10. So we had a 10-point scale where we ask managers and managers from car manufacturing organization and their suppliers to actually rate on this scale these different use cases in terms of the average business value assessment, or the average business value that they expect. Will it be very high for them, or will there almost no business value for them? And as you can see, there are some in the area of until 3 almost, where they said, well, predictive maintenance, visual control, objective labeling, and sequence optimization is of very high business value. Whereas on the other side, for example, if you go to the worker path worker walk path optimization, always kind of challenged by this word combination. We have a 7.2, which is a very low business value assessment in that regard. And we did the same for the realizability, because we said, well, how do you think how easy it is to realize these use cases within the assembly lines that you are responsible for? And we used a scale from which was 1 very easy to 10 impossible. And therefore we see that objective labeling, energy consumption, visual quality control, paint bath composition control, cutout weight reduction, factory energy monitoring are the ones that are more easier to be implemented. Whereas on the other side, there's a group of 2, which is almost impossible to be implemented from their perspective, which is human-robot integration and matrix production. And this is what we then plotted on this graph, because we said, well, we have both a 1 to 10 scale. So 1, sorry, this was 10 is the lowest, 1 is the highest. So we have 1 to 10. And then we use these 2 average values that we got, the mean values, to plot this diagram. Hope that explained that a little bit more in detail how we proceeded here.
Yeah, thank you for that. It was absolutely clear. Thank you.
Yep. Thank you, Professor Sven. I have another question which I have received on a personal chat window from one of the participants. The participant asks as to how can automotive component manufacturers, autocomp, the auto ancillary industries can be motivated into implementing AI and continuing with the partnership with the car manufacturer, because there is obviously a disparity in the scale of operations and also capital intensiveness or intensivity that comes in.
Yeah, one of the challenges here, one of the approaches here is, let's say, a cross-organizational or value chain driven data analytics approach. Because what we see for the automotive industry, as with many other manufacturing value chains, is that there are so many different organizations involved in terms of the integration from the value chain, which is very low, so that each of these organizations have some data available. And what the business value at the end of the day will be if we integrate the data from the different organizations to then have a high quality amount of data available to analyze them and provide insights for all these different stakeholders of the value chain. And I think if car manufacturing industry, car manufacturers realizes that if they integrate their data analytics approaches across their value chain, then also suppliers and other organizations within that value chain will be willing to invest and go into AI-based technologies, because they have a higher quality data set available if they would just use the data that they have, because most of the insights actually comes from if you integrate the data across the value chain and not only use the data from one single organization. Nevertheless, this was one of the factors that I talked about when I said, well, and I talked about the organizational challenges, the data protection and the intellectual properties and so on. This is then one of the challenges, because if this is the data of my organization, that's the data of your organization, that's the data of a third organization, are we really able to share that? Are we allowed to do that? What is the legal framework for doing that? And what is actually finally the intellectual property? Who actually owns the results and the knowledge that we gain when I analyze data that you provided? And these are some environmental challenges where organizations actually are struggling with when they want to implement cross-organizational data analytic approaches, which might actually provide then the motivation for all participants of a value chain to invest in AI-based technologies, because then they have high quality of data available, which they can use for their own purposes.
Absolutely, sir. As you rightly said, I guess, with all participants being equal beneficiaries, I guess it is just a matter of time that they will be exposed to the benefits that are available to reap from adoption of AI. There's another question that has come in, which is, what are the unique challenges of using AI in the automotive sector?
One of the unique challenges in the automotive sector is like when we say, let's take it a little bit broader and say, well, it's the manufacturing sector, it's the installed base, because you really have big machines out there in the shop floors, which you invested money in, maybe already 10 to 15 years ago. And whether, first of all, this installed base enables the use of artificial intelligence, or it requires so many efforts and investments also in terms of money to actually make AI usable in these installed bases of the systems that you actually uses for manufacturing. In comparison, if you are, for example, in a service industry like financial service industry or whatever, yes, you also have a very big installed base, but most of these systems are actually computerized systems, information systems, and you can more easily use an AI-based approach to say, well, let's do some consultancy in terms of which financial products you should use by using a chatbot or whatever, or to make some predictions about the market and so on, because you already have these computerized information systems, which is the installed base that you have. Whereas in manufacturing, and especially in automotive industry, yes, you have in the information systems to manage the production, but the most of the efforts, the most of the money is actually in the physical systems that are producing the cars, and this is one of the main challenges here.
True, sir. Very true. So there's another question that's come in, which requires your suggestions. And the statement is: among the challenges in developing and deploying AI technologies is adequate training of neural networks. In general, more complex the problem, the more complex that the neural network needs to be. That implies large models, training that requires vast resources and expertise to design and test AI models that rely on large data sets to verify these models. How can this be addressed?
Well, I guess the second part of the statement or the question already provided the answer. You need to have these large data sets, because if you don't have these large data sets available, again, that's coming back to my cross organizational argument that you need to have data from different organizations, because if you don't have these data sets, then you cannot actually train and test these complex neural networks or any other kind of artificial intelligence based approach, and then it doesn't make sense to use them. So it's actually, yes, one of the challenges to have these data sets available, to maybe even more standardize the production process, to have less cases where you actually do, for example, visual control with and so on, so that you increase the data set by more standardization, that you have more cases that you can actually rely on, which are very similar. And this is one of the challenges here. It's the data availability and the availability of sensor data, that you actually be able to have data sets for training the models and then applying the models.
Thank you very much, Professor Sven. Thank you for patiently answering all the questions and the requests that have come in. And thank you for, in fact, throwing light on such an interesting and upcoming area. This is an area that probably is going to change the industry and the face of the industry in probably years to come, or maybe lesser than that. And that it's one of the things that's just waiting to boom. So thank you for taking us through such an interesting topic, Professor Sven, today. And we are really indebted to you for taking out time from your schedule. And thank you for addressing us today in this seminar series.
Yeah, Professor, in fact, I got a message from Professor Yogesh Dwivedi. He had a sudden unplanned meeting that he was called into, and hence he couldn't make it. So he has asked me to convey his apologies for not being able to make it for this session. He'll also send a separate email to you about this, but he requested me if I can mention this right during the session. So I thought I'll mention that. And thank you once again for giving your time. And it was really great to listening to you with respect to how you're converting these aspects that you're studying into research papers that are getting published, which also adds a lot of value to the existing body of knowledge. So thank you for sharing all this with all of us. I mean, you'll soon get the video recordings that this session is getting recorded. So we'll be glad if you can post this on your LinkedIn also, #Swansea as well as SIBM Pune while you do that, sir.
I do so. Thank you very much for hosting me, for having me today. It was a pleasure to talk about that and to answer all the questions. It was really interesting to see your thoughts on this matter as well. So thank you very much.
Thank you. Thank you, Professor Laumer. Thank you.